in November of 1895, German physics professor Wilhelm Conrad Röntgen made an unexpected discovery that would transform science and the medical community forever. While working on an experiment with electricity currents, Röntgen noticed a mysterious light shimmering on a screen. When he put his hand between the light and the dark screen, he was able to actually see the bones in his hand. Röntgen called this strange discovery X-rays, and in December of that same year, he exposed photographic plates to the rays and recorded the first X-ray image, his wife's hand.
A view of the bone structure of the human hand, made possible by X-rays. They make the invisible visible. Physicist Wilhelm Conrad Röntgen discovers X-rays in 1895, a milestone in medical history. It allows doctors to see inside the human body without a scalpel. The legendary X-ray sphere in the early 1930s. 40,000 units provide outstanding images. Diagnostic imaging technology develops at a rapid pace, thanks in part to innovative information technology, leading edge of research and development, providing sharper, clearer pictures with reduced radiation exposure. Angiography has been around commercially since 1951. It allows doctors to see blood vessels using X-ray technology. Today, angiography can detect even small changes. Develops real-time ultrasound imaging in 1961. For the first time, organ-related problems can be diagnosed in detail, cheaply, quickly, and without radiation. Today, Line and Acusen ultrasound systems are used around the world. Computed tomography is created in 1972, first medical equipment company to make a CT scanner commercially available. It provides the first sectional images of the body that are not obscured by overlaying structures. CT scanners continue to set medical milestones today. High-resolution 2D and 3D images of the human body. High-resolution sectional images that require no X-rays at all. Magnetic resonance imaging, MRI, makes this a reality in the early 1980s. The technology depicts the function and structure of organs and tissues with unprecedented quality. MRI scanners continue to set new standards worldwide. Nuclear medicine is used to study metabolic irregularities and can depict them visually, helping doctors detect disease at its earliest stages. Positron emission tomography is one of the most powerful types of nuclear medicine scans available. SPECT CT diagnostics via hybrid camera shows where the future of medical imaging is headed. The combination of nuclear medicine and computed tomography allows metabolic processes to be depicted and simultaneously assigned to a precise anatomical location. Wilhelm Conrad Röntgen was the founder of medical imaging. We must follow his example and continue moving ahead with research and development to meet the pressing medical challenges of our time.
X-ray technology utilizes high-energy rays that can pass through certain body tissue and create imagery vital to diagnosis and treatment. The X-ray machine is composed of an X-ray tube that contains a pair of electrodes or conductors called a cathode and an anode. The cathode is a filament that releases energy with the introduction of an electrical current, much like that of a light bulb. The cathode energy is released in the form of electrons. The anode, located on the opposite end of the X-ray tube, is a disc made of tungsten, a material that attracts the electrons. When the electrons released from the cathode come in contact with the tungsten, they release energy in the form of photons. These highly energized photons are channeled through a lead cylinder and a series of filters, creating an X-ray beam. The X-ray beam is a high-energy beam that can be absorbed only by dense body tissues, such as bone. During an X-ray, a radiographic film is placed behind the patient, and the patient is placed between the film and the X-ray machine. The X-ray machine then focuses the energy beam at the specific area of the patient's body. As the X-ray energy passes through the patient's body, the photons of the beam reach the film and cause a chemical reaction. The areas where X-ray energy passes through the body become black, while the areas where energy is absorbed by the bones appear white. This process produces a radiographic, which is commonly referred to as an X-ray.
CAT scans produce 3D images of the inside of the human body. The instrument uses an energy source that emits a fan-shaped beam of X-rays and a receiver or X-ray detector on the exit side of the patient that records a snapshot X-ray. Multiple snapshots, collected during one complete rotation, are sent to a computer to create a cross-sectional image or slice of the body. Between rotations, the body is moved through the machine in increments with an image slice being computed at each position. Every rotation, here speeded up, yields an image of a new slice as it moves through the length of the target, in this case through the head of the person who is lying in the chamber.